Unit 6, Polynomials and Factoring. This is 6.1, of course. We'll start with polynomials, what they are, how they work. Alright, so polynomials are defined as an expression consisting of many terms. An expression consisting of many terms. To be honest, this is a very loose definition because almost every expression is a polynomial. I'll show you what I mean. Alright, so examples. 5, this is what I mean by loose expression. 5 is an expression. It's a term. Thus, it's a polynomial. I know. Alright, so is negative 6x. Even though it's only one term, it's a polynomial. 4x squared minus 1. 2 terms. Polynomial. 9x cubed plus 4x squared minus x minus 2. I know. 1, 2, 3, 4 terms. Still a polynomial. Like I said, a very loose definition. Alright, standard form means to write everything in alphabetical order with the highest exponent first. Alright, so write alphabetical order first. Then highest exponent to lowest. Highest to lowest. Highest to lowest exponent. Quick note, what's an exponent? It's the letter, it's the number at the top. Sometimes it's a letter, that's why I said that. This is the base, it's a variable, this is the exponent. Alright, so if you wanted to do it alphabetical first, you would do x before y, standard form, and then you do highest to lowest exponent. So it would be x cubed plus x2 plus x by itself plus y cubed plus y by itself. Alphabetical first, highest exponent to lowest exponent. The last number should always be the constant because it has no exponent. And it has no variable. It should always be last. Right? It should always be last. Polynomial. Alright, so we're going to write each polynomial in standard form. So the first thing it wants us to do is learn how to put them in order. Remember, alphabetical, highest exponent to lowest exponent. The only variable here is x, so we don't have to worry about the alphabetical. Highest exponents, next highest exponent to constant. Highest to lowest, that's it. Alright, again, all W's, so we don't have to stress about alphabetical yet. Highest exponents to lowest exponent. So W3 plus 5W2 minus W, right? Remember this goes together, plus 28, right? They were almost in order. If a variable has no exponent, there's an invisible 1. That's why it goes third, because there's an invisible 1. Alright, this next one is the first one that has multiple variables. So first we're going to worry about alphabetical. Right, we have A, B, and B. Alright, be careful. This and this are not the same thing. Alright, these ones have the invisible 1 exponent, so they are not the same thing. They have to be identical for them to be the same thing. Alright, so highest exponent first. A comes before B, so A3. and then a to the first or a to the second. Highest exponent first, but then you have to look at AB. A to the second comes next. So plus 5a to the second, b to the second, then 2ab, then minus 2b cubed. So even though this has a higher exponent than that, it comes last because b comes after ab. Alphabetical first. Good. You should be able to do 2, 4, and 6. All right, the next thing we have to separate them is we have to classify them by degree and number of terms, right? So to classify something by degree is to look at the highest exponent, based on highest exponent, based on highest exponent. Right? So when you're looking for classifying it by degree, you're looking at highest exponent of the whole expression or the whole equation. Right? So the different degrees, if it has a 0 exponent or no exponent, right, that's a constant. That's why it always comes last. In standard form, it always comes last. Then we have the highest exponent being 1. That's a linear equation, right? Linear meaning it's going to make a straight line. X and Y, right? Linear equations. 2, if your highest exponent is a 2, it's a quadratic. It's a quadratic. The highest exponent is a 3, it's cubic. Think about like cube, cubed, cubic, 3. If it's 4, it's quartic. Q-U-A-R-T-I-C. Think about quarter, 4 quarters in a dollar, quartic. Right? So if it has the highest exponent of a 4, it's quartic. Right? You can also calculate it based on number of terms. We counted the terms in the first couple of ones. They're all polynomials, which is why you're going to see that it's a very vague description. But if it has less terms, they each have their own name as well. Polynomials, the umbrella term, everything else fits under it. Right? If it's a 1 term, it's a monomial. Mono, meaning 1. If it has 2 terms, it's a binomial. Sensing a pattern here? Bi, meaning 2. If it has 3 terms, it's a trinomial. Tri meaning 3. 4 and up, polynomial. Right? So technically, all of these are also polynomials. But if it has less than 4, it has a specific name. It's like cars. I could say car and it could apply to millions of different cars. I could say Fords and that narrows it down. I could say Ford Escorts, that narrows it down even more. Right? So it's all about categories. Classify each polynomial by degree and number of terms. So it wants to know the level of exponents and how many terms, right? Remember, a constant is a 0, so it's a constant. It has a 0 polynomial. Constant is the name, and it has 1 term. 1 is monomial. Right? It just wants you to label them. This one has 2 terms, so we know it's going to be binomial. And the highest exponent is a 1, and that's linear. So it's a linear binomial. Again, 2 terms, so we know it's going to be a binomial. The highest exponent is a 3. 3 is like cubed. cubic. So cubic binomial. And the reason you need to know the term, the degree here, is because this graph and this graph and this graph are all going to look very, very different. So if you know what it's supposed to look like, it'll help you make sure you're doing it right. All right, you should be able to do 8, 10, and 12. All right, and then when you add and subtract polynomials, you simply combine the like terms. So, crash course in combining like terms. What are like terms? Two constants can be combined because they're like terms. Two variables can be combined because they're like terms. How many x's? 2 x's. Alright, so 5x and 5x can be combined because they're like terms. That would be 10x. It doesn't matter which variable, I'm using x, but it could be y or q or p. It doesn't matter, right? What can't be combined? Alright, 5x and 5y cannot be combined. They are not like terms. So, no. It has to be left just like this. You cannot combine, right? Cannot combine. All right, what else can't you combine? How about 3x cubed and 3x squared? They have the same variable, but they have a different exponent. So you cannot combine those. They have to be identical. Cannot combine. Right? So these can be combined because they both have the invisible 1. These can be combined because they're the same variable and the same exponent. These cannot be combined, and these cannot be combined. Now let's use this knowledge. Alright, so if you're going to add this polynomial, it's a 3-term quadratic, and this polynomial, which is a 3-term quadratic, they're both trinomial quadratics. Okay? If you're going to combine these together, because you're adding them together, you literally just combine your like terms. Because you're adding, combine your like terms. Right? Drop the parentheses. 11x minus x squared plus 13 plus 2x squared minus 23 minus 5x. Right? Drop the parentheses. I literally just took this and dropped it down outside of the parentheses. And then combine your like terms. Remember, standard form. Alphabetical first, highest to lowest exponent. Alright, so we're all x, so we're good. Alright, highest exponent is 2, so start with that. 2x squared minus 1x squared. These can be combined because they're both x and they're both to the second power. 2x squared minus 1x squared is 1x squared. Next up is x by itself. We have 11x minus 5x, which is a positive 6x. Don't forget that positive sign. You have to separate or it's not 2 terms. These are 2 separate terms. Alright? And then let's do orange. We're left with constants. It's negative 23 plus 13, negative 10. Right? All the like terms are combined. That's your answer. You cannot combine that any further because they are not like terms. That's as far as you can go. Right? Now, the only difference with it being subtraction, the only difference is you have to distribute that first. To get rid of the parentheses, you have to distribute it. right? So when you go to get rid of the parentheses, drop down the first one to get rid of the parentheses, 4x squared plus 5x, and then distribute that negative sign. Negative times 7x is negative 7x. Negative times 3x squared is negative 3x squared. Negative times positive 1 is negative 1. This is the only difference. This one drops straight out of the parentheses, combined like terms. This one you have to distribute the negative sign, drop it out of the parentheses, combine like terms. That's the only difference. Right? All x's, so we're good. X squared, 4x squared minus 3x squared is 1x squared. Five x minus 7x is negative 2x. Negative 1 is all that's left. Once you have them all combined, as far as you can, you're done. X squared and x can't be combined because they have different exponents. Even though they're the same variable, they have different exponents. That's as far as you can go. That's the answer. All right, let's practice. Find each sum or difference. Remember, if it has a plus, just drop them outside of the parentheses. Combine your like terms. 4x plus x is 5x, right? 4x plus x is 5x. 5 minus 7 is negative 2. That's your answer. That's it. All W's, we don't have to worry about alphabetical. It's a plus, so all we have to do is drop it down. Make sure you copy it exactly. If you do not, you will make a mistake. Watch your signs. Combine your like terms. The highest is cubed, right? So we're going to go W cubed. Let me change color. And then squared, we have 3w squared minus 2w squared, so we're left with a positive 1w squared. Do you have to write the 1? No. No, you do not. The 1 can be invisible. Completely up to you. Negative 5 minus 11, negative 5 plus a negative 11 is negative 16. Highest exponent to no exponent. Can't wait till we get one that has multiple variables. Eventually. Eventually. Alright, still a plus sign. Drop it down. P squared plus 5p plus p squared minus 15 minus 4p. P squared is my highest. We have p squared minus p squared. That means they're going to cancel out. I don't even have to write that down. It's a 0. Then we have 5p minus 4p, which is 1p. Do I need to write the 1? No. And then we have 8 minus 15, which is negative 7. All of this simplifies to this. This cannot be combined because they are not like terms. This one's negative. Finally, bring down the first part. Distribute the negative sign. Combine your like terms. Negative 3x squared plus 1x squared is negative 2x squared. Positive 17x minus 5x is positive 12x. Another negative. 4c minus 11 minus 4c minus 11. Oh, interesting. 4c minus 4c cancels each other out. Negative 11 plus a negative 11 is negative 22. That's all that's left. Another negative. 7v minus v squared plus 14 minus 15 minus 8v minus v squared. Highest exponent, v squared. Minus v squared plus a minus v squared is minus 2v squared. Remember, there's invisible ones. A negative 1 plus a negative 1 is a negative 2. And then we have 7v minus 8v. We're left with negative 1v. The 1 doesn't need to be there. Up to you. And that leaves us with 14 minus 15. That 1 needs to be there because it's alone. It doesn't have a variable to hide behind. So it has to be there. Alright. Find the sum. Sum means add. Right? It's the same exact thing we were just doing. The difference is they're using the word instead of a plus sign. That's alright. We know sum means plus. Right? We're not slow. 8p squared minus 2p plus 15 plus 11 minus 2p squared minus 1. 8p squared minus 2p squared is 6p squared. There's only a negative 2p, so I guess that comes down. We have 15 plus 11 is 26, minus 1 is 25. Subtract blank from blank. Be very careful here. You're going to want to just put a negative sign here. But that's not what it says to do. That's not what it says to do. It says to subtract this from this. So it needs to be a negative sign, and it needs to come over here. This needs to come over here. 2w cubed, 2w squared minus 5w plus 10. Right? Because it asks us to subtract this from this. That's like if they said subtract 6 from 3. Subtract 6 from 3. They're actually asking you to take 3 and take 6 away. Be careful is all I'm saying. Be careful. Alright, so now we know we need to distribute. So we have w cubed plus 6w squared minus 2 minus 2w squared plus 5w. Negative times a negative is a positive. Minus 10. Now we can combine our like terms. W cubed at the front. 6w squared minus 2w squared is 4w squared. 5w over here by itself. Negative 2 plus a negative 10 is a negative 12. Remember to be careful. If it tells you to subtract this from this, then this has to go after. Just be careful is all I'm saying. Alright, even ones are yours.